So we're going to learn about alcohols, their nomenclature properties, and some of the applications in this section. All right. So first of all, just a little bit about the alcohol functional group. It is ROH, where oxygen is in the middle, and then you have an alkyl group on one side or any carbon group, and then H on the other side. It's one of the most recognizable functional group. Okay, OH, you can see it everywhere. Anyhow, so then the oxygen here is going to be sp3 hybridized. It's a 109 bond angle, so it's kind of bent, and OH itself has very, interesting properties in the sense that, with the hydrogen bonding, and also when we talk about the physical properties, keep that in mind. Oxygen is, highly electronegative. But anyhow, let's go on. So yeah, very important functional group. Okay, as we go on, the other counterpart of alcohol functional group is thiols, in which the oxygen is substituted with sulfur. So, or instead of oxygen, there is sulfur. We will not be doing thiols in our section. We will focus just on the oxygen. So first of all, the nomenclature. Now, alcohols will take priority over what you know so far, which is the alkenes, alkynes, any kind of halides that you might have on there. Any substituent you have, alcohol takes priority. Okay, so the first thing that you do is, of course, you find the parent chain, and alcohol groups the lowest possible number. And priority means, by the way, that you're going to end the name with all. Okay, so that's the whole thing about priority. Priority is two things: giving the name as all, and then also giving it the lowest number, okay, as much as possible. Some of the alcohols are going to have some common names also, so we'll go through them as they come, and then you are expected to know both names, general names, as well as the IUPAC names. Okay, so IUPAC is of course the easier one because they're very systematic, right? That's what they're called, systematic nomenclature. But anyhow, okay, so let's go ahead and start over here. I'm going to go through this fast because this one is pretty easy. So the first alcohol is methyl alcohol, which is also called methanol. So methanol, you guessed right, that's going to be the IUPAC name. Methyl alcohol is the general name. Okay, ethyl alcohol, ethanol, you're going to encounter this a lot in labs because both of these actually are used very commonly as solvents, okay, as is propyl alcohol. So extremely common alcohols. Isopropyl alcohol is propane 2-ol. So now you have to start numbering, okay, with the 3 carbons. So propane 1-ol and then propane 2-ol. 1-propanol, okay, if you find that anywhere, that's the old nomenclature. The new nomenclature is putting the locant right before the functional group, okay, so we put 1-ol. 1-propanol was the old nomenclature. Anyhow, going on to 4 carbons, butane 1-ol, butane 2-ol, and then the T-butyl alcohol, which is now the 2-methyl propane 2-ol. Okay, so the longest chain is 3. So I've numbered the carbons here for you. Okay, so a little bit more on nomenclature here, just a few more examples where you have the substituents here. So I've numbered everything here for you. Alcohol gets the highest priority. Even if alcohol is on the first carbon, you still have to say 1. Always have to tell the locant, okay? And so in the new nomenclature, you are putting the locant just before the functional group, okay? So you see that here also with the hex 5-ene 2-ol. So first of all gets priority, and then the other thing is that the 5 goes before ene. So that's the nomenclature here for alkenes with alcohols. Now, if you have 2 more alcohols, these are called glycols, and glycols are very specific if the groups are adjacent to each other, not on the same one. So 1,1-ethane diol is not considered a glycol. However, a 1,2-ethane diol is considered to be a glycol. Okay, and then here is propylene glycol. So I just want to tell you about something here. And that's 2 things, okay? Vicinal, first of all. So vicinal is when two groups are right next to each other, right? We call them Vic also. So vicinal is right next to each other. It doesn't matter what functional group it is. Could be two chlorines, it could be two alcohols. Okay, that's one thing. And the other thing I want to talk to you about is this ethylene glycol. So here it says ene, okay? And this ene, you might think, oh, this looks like an alkene, but it's actually not an alkene, okay? Ethylene is coming from this group right here, which is CH2, CH2. Okay, that's the group. So when we have a CH3 group, like we have, over here, a CH3 group is considered to be methyl group, right? And if you have a CH3, CH2, that's called ethyl, okay? And that's ethane minus one hydrogen, okay? So CH3, CH3 is ethane. So ethane minus one hydrogen will give you ethyl group. Now ethane minus two hydrogens is going to give you the ethylene group, okay? So you lose too many hydrogens. So for example, and we've done this before also with methylene chloride, like if you have CH2Cl2, so here you've lost two hydrogens from the alkane, okay? So that becomes methylene, all right? So that is how this comes around, all right? The methylene, ethylene is coming from losing two hydrogens and not just one hydrogen. You lose one hydrogen, you become an alkyl, not you per se, but it becomes, the group becomes alkyl group. But if it is two hydrogens, it becomes like an ethylene or propylene, okay? So it has an ene ending to it. So that's where the ene is coming from, okay? Don't let it bother you. So here we have some cyclic alcohols. If you just have the one alcohol group on there, then you don't really have to number, because everybody understands that, that's where you're starting the numbering from. And then even if you have two groups, even in that case, the priority of the numbering goes to the alcohol group, so you don't have to number it, okay? So you just have to number the substituent if there is anything else on there. So here is 1-methyl cyclohexanol, there is 2-methyl. It's just, you don't have to say one all, okay, at the end, because it's understood that one is where your alcohol is, okay? So it's actually incorrect, okay, to put the one there. It's not that it's redundant. It is definitely redundant, but you shouldn't put it, okay? It's not a good idea. Okay, and then benzene with an alcohol group is called a phenol, okay? So phenols we are going to cover, but not here. We're going to cover phenols when we get to aromatic chemistry, because it's part of benzene. So I want to remind you also about the primary, secondary, and tertiary alcohols. So just like any other group, like chlorines that you have learned about, or any halide, any carbon, hydrogen can be primary, secondary, tertiary. Alcohols can also be primary, secondary, and tertiary. A primary alcohol is one that is connected to a carbon, that is connected to only one carbon. Secondary has two alkyl groups connected to that carbon, so that's the two there. And in the case of tertiary, these are three alkyl groups, okay, connected to the carbon where alcohol is. Each of these alcohols behaves differently, okay? They are synthesized differently, they react differently. So our primary, secondary, tertiary alcohols is really, really important for us as we go on. Now for the physical properties, so the boiling point, melting points are going to be high because of hydrogen bonding. As I said, that the OH part there, oxygen is highly electronegative, and so you're going to expect, high boiling points. Remember, when we compare boiling points, we're comparing it with alkanes, okay? So a few things as we go on with all these properties is generally when we say something is high, well, compared to what, So high generally is with alkanes, okay? And you have to kind of say it also. So I always write it, okay? And you also be careful that it's not high compared to water, for example, okay? Water is higher than alcohols. But still alcohols are quite high, okay, as far as their boiling points are concerned. So even the smallest alcohol, which is methanol, is actually a liquid, although the boiling point is not very high. It's about 42 or 46. So it's on a hot day, it is kind of boiling, evaporating. So as you have more alcohol groups on it, then the boiling point increases. As the molecular weight increases, then the boiling point also increases. Okay, so that's the boiling point. Melting point, melting is like nothing, right? Because it's already melted, it's really low. So boiling point is high. Solubility in water is yes, and that's for small alcohols. From now until whenever we are studying, the small, when we say, means 1 through 4. So 1 through 4, sure, soluble. After that, we are up, like we don't know. Something can be soluble, something may not be soluble, depending on what other groups there are. So small alcohols are definitely soluble in water, but as the molecular weight increases because of the alkyl groups, then the solubility decreases, okay, in there. So the solubility decreases as the size of alkyl group increases. Solubility will also increase if you have more alcohol groups, because you are increasing, of course, the hydrogen bonding. So one of the most common alcohol groups are found in carbohydrates, and you know that sugar really readily dissolves in water. There's no issue about that. Sugar has anywhere from, depending on which alcohols, which kind of carbohydrates you're talking about, anywhere from 4 to 5 alcohol groups. So they're readily soluble in water. Hydrogen bonding, okay, again, intermolecular forces, physical properties, a lot of it has to do with intermolecular forces. Odor, of course, does not have to do with intermolecular force. This is by itself. And alcohols generally are sweet smell. I mean, there's hardly any alcohol that you're going to smell and say, I don't like it. Okay, so most of them are actually quite okay. Acidity of alcohols. Now, this is an important part, okay, because alcohols resemble water, okay, and water, HOH, right? So water is H2O or HOH. So we can say that, if you're removing one hydrogen and putting an R group there, then you have, alcohol. So alcohols are also acidic, and just like water, alcohols will also be basic. So we'll talk about that also in a second. So acidity of alcohol means that that the alcohols are able to give a proton. So the pKa range is this much. Here is the one for water. 15.7 is the pKa. Remember, the lower the pKa, the stronger the acid. So here, I mean, it's it's almost like water only, okay, as far as the acidity is concerned. So, but the acidity is going to decrease as the alkyl group increases. Why? Because you have electron donating effect. Remember, for anything to be acidic, you have to be able to give the proton. So this proton is the acidic proton, not the CH3 one. This is the one because it is connected to oxygen, which is more electronegative. So this bond is the polar bond. So this hydrogen is the one that is the acidic proton. And so you want this hydrogen to go away. When you have more alkyl groups, they tend to donate electrons, and if they donate electrons, they're kind of holding on to the hydrogen. If they're holding on to the hydrogen, it is not going to want to dissociate. So this then propanol becomes less acidic. Okay, so methanol is most acidic, and then least is the propanol in this category. Okay, however, if you put like an halogen, especially a halogen as electronegative as fluorine, now fluorine is going to pull electrons towards itself, and when it does that, okay, so for example, let me show you here, when it pulls electrons towards itself, then the OH bond is weakened, okay, and when that OH bond is weakened, then that proton can leave. Okay, so here you have fluorine, here we have chlorine, so fluorine is more electronegative, causing this alcohol to be more acidic, okay, in its properties. So again, if you have more chlorines, then you have more electronegativity than just one chlorine, and I should say more inductive effect, because the inductive effect is really what's pulling electrons towards the chlorine. So this bond is weakened. Okay, now because of this acidic proton, right? You can react with bases. Now, it's not that super, acidic in nature, so you need a nice good base. And generally, a good base is going to be sodium or sodium hydride. Okay, sodium hydroxide can react, there is no doubt, but there is other issue with sodium hydroxide, and I can explain that in another video. But sodium hydroxide is not the best base for abstracting a proton from alcohols. So you can use sodium hydride, and then create the alkoxide, which in this case is methoxide. Remember how they're called, okay? So just like you have for water, it's called hydroxide. So here for alcohols, you remove a proton, and whatever alkyl group you have, say here is methanol, methanol gives methoxide, ethanol gives ethoxide, and so on. Okay, so learn the nomenclature also of these. So these are good bases to abstract a proton. Okay, again, you need a nice good base, okay, to remove a proton. Okay, so here's the basicity for alcohols, and basicity means that now the oxygen group here, which has the lone pair of electrons, now that's going to be the sort of a Bronsted base, or you can call it a Lewis base also. And so it, picks up a proton. So now you can have any kind of acid here, HCl, H2SO4, whatever acid it is, it's going to get protonated. Okay, so the alcohol gets protonated into this kind of an oxonium ion, and we're going to see this a lot. So I want you to get comfortable with the oxonium ion. Okay, so wherever oxygen is protonated with 3 bonds on it and a positive charge, that's an oxonium ion. Extremely common for us wherever you have oxygen containing groups. Okay, so this is going to be now the protonated alcohol. Okay, so in any case, here is another example of just an alcohol reacting with another alcohol. So you have alkoxides, which we generated in the in the slide before. So now that's become a very strong base, and so this nucleophile is now picking up a proton. So I mean, like, all you've done is a proton exchange. Applications of alcohols are many, and I don't want to spend too much time on this, but still, this is just very interesting stuff all over. Methanol is a very, very common solvent. We use it in the lab also, and industries also use a lot of alcohol, methanol as a solvent. It's also called the wood alcohol because it was originally obtained from wood. And in a lot of the labs, wherever you have little spirit lamps, that spirit lamp is actually burning methanol. So it's an extremely common, okay, but it's very toxic also. It doesn't kill you, but it will, cause blindness. So yeah, you've got to be careful, all right, with methanol. Don't drink it. Ethanol is the drinkable kind, not that it is any better than methanol. Ethanol has its own problems. But anyhow, first of all, you can form ethanol from any kind of carbohydrate, right? So we know, of course, it's such a big business. Beer, wine, whatever is just a huge business of, making alcohols. And so the distillation, produces then hard liquors. I mean, distillation is required for almost everything, but still, you can get really, and what hard liquors really mean is that you have a higher concentration of the alcohol, but alcohol can never be 100% ethanol because it forms an azeotrope with water, and whenever there is fermentation going on, there will always be water. And so azeotrope means that you have a mixture with water, at least for alcohol. Azeotrope is just a mixture that you can't separate, okay, a mixture of liquids. And ethanol will always be 95% ethanol, which means that 5% is water, okay, in there. In the lab, we actually need dry alcohol, and that means, that you have 100%. Denatured also means that it is made into the undrinkable kind, okay? So even though we have 100% ethanol, we also make it to a place where you can't drink it, okay? It's got some toxin in it that you cannot drink, okay? Because otherwise everybody would just come to the lab, right, and drink. So not a good idea, okay? So Anyhow, so that's that. Ethanol is also used as fuel, okay, and so wherever you see gasohol, that's actually ethanol in there, okay. Just a little bit about the drinking alcohol as far as the ethanol is concerned. It's got its own issues, you know, and so we say methanol is toxic, but ethanol is toxic as well. It's very addictive in the sense that, you know, anybody who starts drinking alcohol, you know, gets tolerant to the alcohol, which means that they need more and more. It's also very hard to get off the alcohol because then your body is physically used to it. Okay, psychological dependence and then physical dependence both happen with alcohol. So there's different kinds, and then you also get different kinds of toxicity with it, which means that you can either become an alcohol, not you, anyone can become an alcoholic, which is like a chronic problem over a long period of time. And if anyone drinks too much of alcohol in a short period of time, like binge drinking, for example, that also has toxicity, and that's called acute toxicity. So, you know, ethanol has its own problems, you know, with the drinking kind. So, something to be aware of, okay, as we go on, because alcohols are, you know, extremely common and they're everywhere. Some of the other alcohols that are of interest to us is isopropyl alcohol, which is a very good disinfectant. You find that in the pharmacy also. By the way, you know, ethanol is probably the only alcohol that's even a little bit drinkable kind. All other alcohols, you know, it's not a good idea to drink any of those, okay? And anyway, keep away. Ethylene glycol is an antifreeze which is used in the car, and this is a very common problem for pets, you know, because if there's a leakage in your antifreeze in the car, then the pets can actually lick this and then they can get toxicity from it. Okay, so be careful about that in case you have pets. Glycerol is used in medication, again, not to be swallowed, but it is used a little bit as a disinfectant also. And then finally, we have sugars. Now, sugars is probably the only kind of alcohol that you can consume, and it's not really considered alcohol that way. It has alcohol groups and not considered alcohol as you would call ethanol. But sugar does have many, many alcohol groups, you know, in it, and sugar is, as you know, very sweet. Um, it's also very addictive, okay, and sugar, you can wean yourself off of sugar also if you want to, okay. But anyhow, so you can see alcohols are all around us. So that's all I think we have in this one, so that's it.